Thank you very much. You're welcome again. I want us to look at briefly how we can use the Newton's laws to prove the law of conservation of linear momentum. Before we can use the Newton's laws to prove the law of conservation of linear momentum, we need to know what does the law of conservation of linear momentum states. The law of linear momentum states that the law of conservation of linear momentum states that when two bodies collide, their momentum before collision is actually equal to the momentum after collision. And we have to use the Newton's laws to prove that this is actually true. So we can have two bodies of masses m1 and m2 colliding. So I can have two cases. This is before collision, and then I can have another one is after collision. Those are the two cases we shall have. We shall have a body of mass m1, then I'll have another body of mass m2, like that. So in this case, we shall have this body moving with velocity u1, and then I'll have this one moving with velocity u2, like that. This is the horizontal surface or the horizontal ground. Then after collision, we shall have the two bodies are that. Then I'll have this is m1, this is m2. These two bodies after colliding will move with different velocities in different directions, like that. So you realize that in the process of impact, body m1 applies a force F1 on body m2. Then m2 in turn will also apply a force F2 on 1. These two forces are actually equal, but only that they act in opposite directions. So in this case, I'll have that the force F1 applied by a body M1 on body 2 is got from the Newton's second law, which tells us that the rate of change of momentum is actually directly proportional to the applied force. So the applied force is going to be F1 on 2, and the momentum change is actually the rate of change of momentum of a body M1, which is actually applying the force. So we shall have M1 V1 minus its momentum after collision minus its momentum before collision out of T. This is from the Newton's second law. And the next is the force applied by body M2 on 1. F2 on 1 is got by M2 V2 minus M2 U2 out of T. And this is Newton's, we have used Newton's second law. Now, we are going to bring from Newton's third law, we shall have that the two forces F1 on 2 is equal to negative of F2 on 1. It means the force applied by a body M1 on body M2 is actually equal to a force that is being applied by body M2 on 1. But they are only opposite in direction. That tells us that actually comes from the Newton's third law, which says that when two bodies collide or interact, the action and reaction forces are actually equal, but then in opposite directions. So we have that. So I will have M1 V1 minus M1 U1 out of T is going to be negative of, I'll have M2 V2 minus M2 U2 out of T. So I'll have this T cancels out, and then I'll have M1 V1 minus M1 U1 will be equal to negative, I can multiply this, I'll have negative of M2 V2, then plus, I have this and this becomes a plus M2, and then U2. That is what we have. I can collect the like terms. The terms that have the same velocities. This is velocity before collision and then velocity after collision. I can have the terms that have velocity before collision together, and then I have the terms that have the velocity after collision or final velocity also together. So I will have negative m1 u1, this one before collision, minus, when I bring this way it becomes minus m2 u2 is equal to, I'll bring this is going to be m, this is negative m2 v2. When I bring this one, I take it the other side, it becomes negative m1 v1. So when I divide all through, dividing all through by negative. So when I divide all through by negative, I'll have that m1 u1 plus m2 u2 becomes m2 v2 plus m1 v1. This is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This one is the initial momentum, actually momentum before collision, and this is momentum after collision. So it means we have actually used the Newton's laws to prove out the law of conservation of linear momentum. Thank you very much. Please subscribe if you have not yet subscribed, such that in case I upload any important video, you can be able to get notified. Thank you very much.